Now student, we are going to discuss question number 5.16, and again this question is related to magnetic materials and there are some fact based question are here, clear? But if you think logically, you can easily give answer of each and every part of this question, clear? So now we are going to discuss first part number A. In part number A it is given, why does a paramagnetic sample display greater magnetization when cooled, clear? So let's suppose we have a paramagnetic substance, clear, and let's suppose we place that paramagnetic substance in a magnetizing field, clear. Now we know in a particular magnetic materials we have atomic dipoles, and that atomic dipoles are aligned in a particular direction, yes or no? So now we can say whenever we are saying that temperature is decreasing, so whenever we are saying temperature is decreasing, so the randomness, we can say the randomness due to thermal energy that decreases, yes or no? And we can say the distortion of atomic dipole that becomes very less, yes or no? Because if there is a more random motion will be there, definitely alignment, there is a difficulty of an alignment in an atomic dipole in a particular direction, clear? But when temperature is decreases, at the time that random motion is decreases, it means we can say paramagnetic substance display greater magnetization, clear to you? So this is all about part number A. Now if I talk about part number B, in part number B it is given to you, why is diamagnetism in contrast almost independent of temperature? Now listen carefully. What is the property of diamagnetic substance? Let's suppose if you are placing any diamagnetic substance in any magnetizing field. Let's suppose I am saying this is a diamagnetic materials, clear, and let's suppose you place in a magnetizing field. Let's suppose that is H, clear. Now we know an atomic dipole, or we can say due to this magnetic due to this magnetizing field, induced atomic dipole is generated in a diamagnetic materials like this, clear, and due to which we can say an induced magnetizing, or we can say induced electric field that is produced here in an opposite direction, clear. So we can say definitely either we are increasing temperature or we are decreasing temperature, there is no relation that there is actually this opposite induced electric, we can say induced magnetic field that is always produced, clear. I think you are getting my point, what I want to say. Whenever we place any diamagnetic material in a magnetizing field, definitely here an induced, or we can say opposing electric field that is produced here. So opposite the direction of this induced electric field in an opposite direction of this field, it means we can say either we are increasing temperature, we are decreasing temperature, but we always find this in an opposite direction, clear to you? That's why we can say it is the diamagnetic property of any substance, magnetic material, it does not depends on a temperature, or we can say it almost independent of temperature, clear to you? Now if I am talking about part number C, if a toroid use bismuth for its core, will the field in the core will be greater or slightly less than when the core is empty? So listen carefully. Let's suppose if I am drawing here, let's suppose this is a core, let's suppose this is core, clear, and here we have a toroid. Let's suppose this is toroid like this. Toroid is something like this. Like this, clear. So let's suppose this is a toroid, clear. Now in this question it is given, let's suppose initially we have this core empty, clear. You know very well, whenever we are talking about toroid, uniform magnetic field that is produced inside this toroid only, clear. Let's suppose current is flowing in a particular direction like this, clear. Let's suppose current is flowing in a toroid in a particular direction. So now we can say we can say uniform magnetic field is produced inside this toroid only. This is clear to everyone. But let's suppose in this question it is given when core is empty here. Now let's suppose we are filling, or actually we are using here bismuth for its core. Now what is concept here? Concept is very simple. If we are taking bismuth as a core. Bismuth is actually diamagnetic substance. Diamagnetic substance. So we can say whenever we are applying here magnetizing field from outside, and because this is a diamagnetic substance, so net magnetization, we can say net magnetic field that is decreases inside core. Clear? So what is answer of this question? If we use toroid having bismuth for its core, field in the core will be slightly less than when core is empty. Clear to everyone? So correct answer is what? This is slightly less than. Clear to everyone? Yes. Now we are going to discuss part number D of this question, and in this question it is given to you, is the permeability of a ferromagnetic material independent of the magnetic field? Yes. No. Yes. We can say, is the permeability of a ferromagnetic material independent? No. Clear? Because let's suppose if I draw here BH curve, you know what is the shape of BH curve? So we can say this shape will be look like this. It will be like this. Clear? Like this. So now listen carefully what I am saying to you. Because this is a BH curve and we know mu, this is given by B by H. So we can say slope of BH curve, it provides you the value of permeability of that magnetic material. Yes or no? Yes. So yes. So slope of BH curve, it provides you permeability. Yes or no? So whenever it provides permeability, so now listen carefully. Initially, just a minute. Again I am drawing. It's like this. Now you can say, if I am talking about initially, so let's suppose this is O point. Clear? And let's suppose this is A point. So from O to A, you can say its slope is actually continuously changing from point to point, and you can also observe for lower value of magnetic field. Clear? Slope is more. Yes or no? So it means we can say permeability of a ferromagnetic material independent of magnetic field? No. If not, it is more for lower or higher field. So definitely we can say for lower magnetic field, the value of permeability for a ferromagnetic substance, it will be more. Clear? Because you can say if you are talking about slope is more at this point. Clear? Let's suppose if you draw here the tangent and if you draw here a tangent, definitely you can say here we are getting slope that is more. Clear? So correctly we can say it is more for lower field. Clear to everyone? Yes. Now we are going to discuss part number E. In part number E, it is given magnetic field lines are always nearly normal to the surface of ferromagnet at every point. Clear? This fact is analogous to the static electric field lines being normal to the surface of a conductor at every point Y. Clear? Now listen carefully. Magnetic field lines are always nearly normal to the surface of ferromagnet. Now what is the meaning of this statement? Now we know very well, actually there is a concept. Concept is what? Listen carefully. This is a concept. Whenever we are talking about relation between B and H, and if we go for a higher calculation that you will learn in the next higher classes. So whenever you will find a relation between magnetic field and we can say magnetization. Clear? So at that time you will find there is definitely we can say permeability is related to B and H. Clear? Now for a substance or we can say for a medium that is having permeability is very greater than 1. Clear what I am saying to you? Because it is given in a question, we have ferromagnetic substance, and for ferromagnetic substance we have value of permeability, this is very high. Clear? Or you can say more than 1000. Clear? So whenever we have value of mu, this is very greater than 1, at that time we can say yes, magnetic field lines are always normal to the surface of ferromagnet. Clear to everyone? So you have to keep only one thing in mind. For ferromagnetic substance, whenever magnetic field lines comes, it always incident normal to surface of ferromagnet. Clear? So this is all about part number E. Now if I talk about part number F, in part number F it is given, would the maximum possible magnetization of a paramagnetic sample would be same order of magnetization as the ferromagnet. Now listen carefully. Now we know in paramagnetic substance, definitely some of the atomic dipoles are arranged in the direction of magnetizing field, but in a ferromagnetic substance we know there is a domains. Clear? And if I am talking about domain, clear, so definitely in a particular domain all the atomic dipoles are arranged in a particular direction. Clear? So definitely we can say permeability value is more in ferromagnetic substance compared to we can say paramagnetic substance. But is it possible that we can reach any paramagnetic substance is nearby or it is having same property as ferromagnetic substance? Yes, it is possible, but only in one condition, when we apply a very high magnetizing field on paramagnetic substance, and that is practically not possible. Clear? So it is given, would the maximum possible magnetization of paramagnetic sample of a same order of magnitude as the magnetization of a ferromagnetic, it is possible? Yes, this is possible when we apply a very high magnetizing field to a paramagnetic substance. At that time definitely some property will differ from ferromagnetic substance, but it will actually find we find here nearly same magnitude of magnetizing field as the ferromagnetic substance. Clear? So this is all about this question.